Alright, hello everyone, this is Mr. Crozier, and we're going to do problems 4 and 5 on the assignment today. What we are doing first, we are taking this equation and graphing it, and the first step we had to identify all of the parts to this graph. So we had an A, B, H, and K, and that follows this formula, y is equal to AB to the x minus H plus K. Alright, what is the A value here? Well, it's 5. It tells us something about the graph. The B value is a 3. The H value is a 0. And the K value is a minus 10. So now that we have those, we can talk about the graph. We talked about what all these meant yesterday. This is the starting value. And this is the growth factor. And this is the left or right. There is no movement left or right. And this is a negative 10 downward shift in the graph. So, alright, we're going to pull this H up here in the middle of our table, and then we're going to count up 1 and 2 and negative 1 and negative 2. And now we're going to take our time and we're going to place all of these values in for x, fill out our table. And it looks like this. We have 5 to the third power raised to the 0 minus 10. 3 to the third power is 1. Or sorry, 3 to the 0 power is 1 minus 10. 5 minus 10 is a negative 5. And that's all the process you're going to repeat. And then you're going to plug in a 1 here, get an answer. I'm going to tell you it's 5. You're going to plug in a 2, get an answer, it's 35. Then you're going to plug in a negative 1, and you're going to get some fractions on this side, possibly. Well, you're going to get fractions all over, but if I plug a negative 1 in there, I have a 5. 3 to the negative 1 is 1/3 minus 10. And this is 5/3 minus 10. And now we have a fraction problem. There's several different ways to do it. I'd probably start by making that a negative. I'd probably start by saying this is 1 and 2/3 plus negative 10. And if you owed someone $10 and you gave them $1 and 2/3, you'd be down to 8 and 1/3. Or you can get a common denominators. However you want to go from here to here, computation wise, is up to you, but the answer is negative 8 and 1/3. Alright, and negative 9 and 4/9 if you do the math there. Alright, now we have to graph that, and one of the things we want to do is spread out our graph. I mean, we're only going to 2 right here, so it doesn't make sense to count 1, 2. I'm going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and that's 1 and 2 spread out. And I'm going to count the same way this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 2. And going up and down, wow, I have to get to 35. And again, I have 10 boxes, so I'm just going to count by 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 4 is 40, and a negative 40 down here. And I might just go 4, 8, 12, 16, 20 is right in the middle, and 20 would be right in the middle here. 1, 2, 3, 4, 5, 20. So however you want to scale it, your graph may be different. I scaled it, try and spread it out as far as you can. Alright, now to graph this. Well, the first thing we want to do is graph this asymptote right here. Negative 10. Find out where negative 10 would be. 4, 8, 12, so 10's right here, right in the middle. That line is straight side to side. That gives you, and this is y is equal to negative 10, this gives you a border to draw the rest of your points. Now you can go ahead and plot them. And we have 0, negative 5, well that's somewhere right in here. 1, positive 5, well 1's way out here. 4, about right there, and 2, 35, way up in here somewhere. And then these other ones, they just keep getting closer to this. So this is our graph. Again, it's an exponential graph. It starts off slowly and then it goes up quickly, and that's what we mean by exponential graph. Alright, when you're done with this, always go back and check them on Desmos.com. I have a PDF picture of it in there, but you can plot this equation, you can plot these points, and you will see everything lines up. Your 5 points, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, will be exactly on your graph on Desmos, and if they don't, something's wrong. Alright, let me give you a bit of help on number 5 right here. I'm not going to do all of it, but it's the same process. We have the A value, the B value, the H value, and the K value. Well, the A value, let me write that formula again. It's a standard form for a exponential equation. A value -2. That means it's upside down. B value 3/2. That's the growth rate. The H value will be a -1 here, so it's 1 to the left. -1 makes this 0 here. And the K value, there is nothing there, so it's 0. 0 up or down. Alright, let's plot in the points here. We have a -1. We pull this up to the middle. 0, 1, -2, -3. Again, you're going to do some work with fractions here. I'm going to give you the table. It's -8/9, -4/3, which is a -1 1/3, -2, -3, -9/2, -4.5. Check those numbers, make sure you can get them computation-wise. Let's see here. I'll go ahead and do the first one. Let's do this one. -2, 3, -3 plus 1. So I plugged in a -3 there. Now I'm going to do this math. It's -2, 3/2 to the -2. What does a negative do? Well, negative flips this and a 2 squares it. So I'm going to have -2 times 4/9, which is just -8 ninths. And that's how you get it. When you graph this one, well, what do we see here? The asymptote is at 0. It's not moved up or down. So our line is here. And all of these points are negative. So our graph is going to be somewhere down here. I'll let you graph it. You can plug that in Desmos to see. But it'll be somewhere down here. It might be going down this way. Or maybe it's going this way. But it is in this lower quadrant because everything is negative. The starting value is negative. So we have a graph down here. And I'll let you graph that on Desmos to check. Alright, finish all 8 problems. You can check them all on Desmos.